Alright, so 9-20, it says use any algebraic solution method to calculate the points of intersection for the system given below, if any exist. Explain what your solution indicates about the graph of the systems. Okay, so what we've learned about graphing systems of equations is we set them equal to each other. So when you do that, we can see that this equation here, we can substitute it in for y because it equals y. So we've got minus x squared plus 4x minus 1 equals x squared minus 4x plus 5. So what we have to do is get everything to one side. So I'm going to add x squared, and I'm going to go this way. So add x squared, so this is going to be 2x squared. Subtract 4x, that's going to be minus 8x. And then add 1 is plus 6 equals 0. And then what I notice is I get 0 equals 2 times x minus 4x plus 3. And so then I think this is going to be factorable, so then I'm going to get 0 equals 2 times x minus 3 times x minus 1. And so my solutions are going to be 2 equals 0, x minus 3. Alright, so then we have x minus 3 equals 0, so x equals 3, and then x minus 1 equals 0, so x equals 1. Whoopsie, 1. Okay, and so those are x values, so now what I have to do is plug those back into one of the equations, and so we get y equals 3 squared minus 4 times 3 plus 5. So we get y equals 9 minus 12 plus 5. So y equals 9 minus 12 is negative 3. And then negative 3 plus 5 is 2. So when x is 3, y is 2. And then we solve y equals 1 squared minus 4 times 1 plus 5. So then y equals 1 minus 4 plus 5. So then y equals 1 minus 4 is negative 3 plus 5, which y equals 2. So then we get when x is 1, y is 2. And so they wanted us to find the points of intersection below, if any exist, and explain what your solution indicates. So basically our two quadratic equations are intersecting in two places, so these are our 2 points of intersection.